right, hello there. Today we're going to be doing exponential. Actually, we're not doing exponential. We're doing logarithmic graphs, which is actually the inverse of an exponential function. So logarithmic, say it's log for short, L-O-G, log for short. So we're just going to explore graphing today. We're not going to get into any kind of converting from one to the other, which is actually really important. That's the next thing we're going to do. Today we're going to stick with just graphing because although it's similar to an exponential graph, it's actually the opposite because they're inverses. So let's go ahead and get started here. We're going to start with just a simple old 2 to the x, an exponential function. As you guys, in the past, we've been using 0, 1, -1, 2, -2. And we graph this. We already know how to graph this. So I'll plug it in though. 2 is 1/2. We actually already know how to graph this guy. So we have a horizontal asymptote at y equals 0. We have the point 0, 1, the point 1, 2. Remember we did 0, 1, 1, b. Our domain was all real number. Oops, sorry. Oh, here I go again, being a terrible grapher. Okay, arrows on the ends. Our domain, all real numbers. The range was 0 to infinity. Your asymptote was y equals 0. Your y-intercept was 0, 1. As x goes to the left, y is approaching 0. As x goes to the right, y is approaching positive infinity. And this is increasing everywhere along the domain. All right, so we already know how to do this. And again, this is really important, the 0, 1, 1b, because what we're going to do next is we're going to graph the inverse of that. And so instead of doing, I'll just, yeah, we're switching x and y. So we did, I don't know where my pen is. It disappeared. I don't know where my pen is. Hold on. I'm going to have to hit pause because I can't find my pen. Found it. Okay, so we're going to switch x and y, 0, 1, -1, 2, -2. All right, and remember, we had the point, I'm going to write this here, we had the point 0, 1, 1b, right? So if we're going to do the inverse of this function, we're going to do 1, 0, let's see, 2, 1, and we'll do 1, 1, 0, 2, 1. We had -1 and 1/2, so 1/2, -1. We had, I don't remember what we had. What points did we use up there? Yeah. I'm going to have 4, 2. And then we had, let's see, remember what we had. Why can't I do that? 1/4. Can't remember what we were using. All right, so 1/4 was a -2. And if I make x smaller and smaller, 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 smaller as I get closer to 0, you're going to notice that you're never going to cross x equals 0. So you have this function that looks like this. Oops, don't pass that. Don't cross that. Okay. Now you're doing the inverse. Okay. So I'm going to erase that so I don't want you to be confused. So for this inverse here, notice our domain is 0 to infinity, and our range this time is all real numbers. If you're switching x and y, that makes sense, right? Your domain and your range switch places with that other graph. And I'm going to actually go ahead and show the other graph real quick on here. You had 0, 1, 1, 2. It looked like this. Okay. This was y equals 2 to the x. Okay. All right. So back to the inverse graph here. And you didn't have a y-intercept on this one. You have an x-intercept at 1, 0. And that makes sense because if you switched 0, 1, you now have 1, 0. Your asymptote is vertical this time, not y equals 0. It's x equals 0. And I didn't draw it because it's going to make it kind of messy, but you have an X. I go ahead and do that, I guess. Now, what was different about the limits, now remember, or not the limits, sorry, I'm teaching calculus. This is a calculus concept, by the way. See up here, we were doing as X goes to the left and X goes to the right. Well, down here, we can't do that because your graph doesn't go, this particular graph doesn't go to negative infinity. It only approaches 0. This little plus here means from the right. So as you approach 0 from the right side of 0, where's your y value going? Well, your y is going down to negative infinity. It's supposed to be negative infinity. As you approach 0 from the right, it's going down. As x goes to the right, your y value is going up. It's not going up very quickly on this graph, but it is going up to infinity eventually. This graph is increasing on your domain, not from negative infinity to infinity, but from 0 to infinity. Okay, and what you guys are doing here, let's grab this little dotted line here. Ooh, that's thick. Try that again. I'm trying to draw the line y equals x. That's not working very well. Okay, you have this line y equals x, and it is an inverse. It reflects over the line y equals x, and we just had a unit recently where we talked about switching x and y and getting y by itself. Well, that's essentially what this is. This is called a logarithm. Okay, it's called a logarithmic function, short for log. Okay, so now what this particular graph here actually has a base of 2. This is called your base. And I'm not going to, without going too further, and here's too detailed on this, we're just graphing on these. But this is your y value, and then you have your log, and then you're going to have this base of x. Okay, so we say log base 2 of x. Make sure you know how to say it. Log base 2 of x. Okay, and the base is 2 because it's the inverse of 2 to the x. Okay. All of this is sort of summarized here, but the inverse of f of x equals b to the x is called a logarithmic function with base b. It's read log base b of x. Log base b of x. The graph of exponentials and their inverse logarithmic functions are a reflection over the line y equals x. So what is, just like we did when we did exponential functions or exponential graphs, we talked about the parent graph, right? Now here, everything is flip-flopped, right? Your domain is 0 to infinity, but your range is all real numbers. You have an x-intercept, not a y-intercept. You have an x-intercept. You have an asymptote. This is for the parent graph. You have a vertical asymptote, not a horizontal. And another good point is B1. So I want you to make sure you write this down. So for exponentials, we use 0, 1, 1b. Remember, if b was a fraction, we use negative 1, 1 over b. Now, don't write this here. I'm just reminding you of that. So when we're doing log graphs, you got to switch those x and y's because they're inverses. So we're going to use 1, 0, b1, or if b is a fraction, you're going to do 1 over b, negative 1. Sorry, that's so messy. We'll have a few functions that have a fraction base, but most of the time they're not. So we'll be using the 1, 0, b1, but I'm not saying that you're never going to have them, but I want you to be prepared for that. All right, so let's go ahead and graph 5 to the x. So 5 to the x is exponential, so we're going to do 0, 1, 1b, 0, 1, 1b. This is an exponential graph. It has a horizontal asymptote. Your k value is 0, right? Plus k. So your horizontal asymptote is 0. And I see that these notes have two different graphs. I really like to graph them on the same one. I won't do that, but um, just because it's here, but it's really nice to see that reflection over the line y equals x, but we did it on the last example. So here we have log base 5 of x. So this is a log graph. This is going to have a vertical asymptote. And I'm going to write this down just a second. So we're going to have the points 1, 0, b, which is 1, which is 5, 1, 1, 0, b, 1. So 1, 0, x-intercept, and then 5, 1. And I'm going to graph this. Let's go ahead and get the asymptote on here at x equals 0. Ugh, that's a terrible graph. Horrible. Supposed to be very curvy, like just like our exponential graphs. Now, one thing I'm going to point out. So remember over here with the exponential function, right? We had y equals a times b to the c x minus h plus k. Remember k was your horizontal asymptote, right? And this one had k was 0. With a log function, your asymptote is not k. It's the well, I didn't write it out yet. It's h, basically. It's your horizontal shift. So when you look at log base 5, this is basically x minus 0. Okay, this h right here, your whatever's here, that is your asymptote. And gosh, I cannot tell you how challenging this is as you move forward through logs and log graphs, is that you have to remember that this h value is your vertical asymptote. So let's take a look at that on number 2. Number 2 here does have an h value, and you also have to remember that this is left 3. Okay, this is left 3, not right 3. So it's not written here, so I think I'm going to go ahead and write this. It doesn't matter if I use g of x, whatever. You still have a, you have log, you have your base, x minus h plus k. Now I didn't put a c in here. You can have a c right here. I should have put that in there. So a is your vertical stretch or compression, k is your vertical shift up and down, h is your left and right, and c is your horizontal stretch or compression. So when you see this, you need to know that left 3 is your vertical asymptote. And that is the first thing that we should always graph. You know how we did exponential functions? I said always graph your k first when we're graphing. Here you're going to graph your h first, and it's always the opposite. Okay, so 1, 0, b1, and this goes left 3. There's no other transformations here. We're going to subtract 3 from the x values. So your two new points are going to be negative 2, 0 and 2, 1. So negative 2, 0, 2, 1. And your graph. So it's almost easier to go up and over for me. Okay, so your domain, negative 3 to infinity. Your range is all real numbers. Your x-intercept is negative 2, 0. As x approaches negative 3 from the right, so as you travel along your graph and you approach this asymptote, as you approach that asymptote from the right side of it, your y values are going down to negative infinity. And as x goes to the right, your y values are going up slowly but surely to infinity. This graph is increasing on your domain. Make sure you're doing your domain. It's restricted, so it's not all real numbers. Okay. All right, let's do a few more graphs. I'm going to describe the transformation as well. This is our parent graph, 1, 0, B1. There is no transformation on the asymptote here or on the function, so x equals 0 is your vertical asymptote. You have a point at 1, 0, 4, 1. Now this one is going down. Notice it's outside. This is not the same thing as x minus 1, okay? Not the same. This is down 1. So you're going to take your points 1, 0, B1, and going down is changing your y value, so you subtract 1. So your new points are 1, negative 1, 4, 0. You have x equals 0. You did not move your graph left or right, so you have an asymptote. I didn't even finish answering those questions, did I? Sorry about that. You are graphing 1, negative 1, and 4, 0. So it looks the same, except for the graph went down 1. I totally didn't even answer these questions. Sorry. So domain, range, as x approaches 0 from the right, your y value is going down. Obviously, that's going to change if you have a vertical reflection. And this is increasing from 0 to infinity. This one, nothing much has changed. You still have your domain. Your x-intercept, of course, changed. X-intercept is 4, 0. Asymptote is x equals 0. As x approaches 0, y is approaching negative infinity. None of this part changed, just your x-intercept. All right, let's try another function. Here we have a fraction base, and so I want us to try, instead of doing 1, 0, b1, I mean, you can, but you're going to get fractions. I would really like for you guys to try 1 over b, negative 1. There's no transformations here, so I don't want to use this. It is correct, but I want to avoid fractions. So let me pull this up just a tad bit more. It's a little tricky. All right, so we have 1, 0, 2, negative 1. See how this one's below now? It did not move left or right, so we still have an asymptote at x equals 0. Okay, and then now this one goes, I should get a little bit closer to the asymptote. Ooh. Okay, that was terrible, but you're used to that by now. Okay, so our range is still all real numbers. Our domain is 0 to infinity. X-intercept is 1, 0. Now be careful here. As x goes to the right, or excuse me, as x approaches 0 from the right, as x approaches 0 from the right, so you're traveling, as you get to 0, your y value is going up. As x goes to the right, your y value is going down. This is decreasing from 0 to infinity. Okay, so we're going to take our parent point, 1, 0, 2, negative 1. And this has two transformations. One is affecting the y values. You're going to multiply y values by negative 1. And this goes right 2. So add 2 to your x's. Now, what you just found out, this h value is your asymptote. It went right 2, so make sure you have a positive 2 here, not a negative 2. All right, so what are our new points here? 3, 0, and 4. Negative 1 times a negative 1 is 1. So 3, 0, and 4, 1. All right, and domain is 2 to infinity. As x approaches 2 from the right, your y value is going down. As x goes to the right, your y value is going up. This is increasing again. So the negative sort of kind of, I don't know, negates, I guess, the fraction that you have on the base. It looks like a normal log base 2 minus x minus 2. Okay, all right. All right, there are two special logs that you need to know, and you guys are going to be using these for several more years to come. If you stick with higher level mathematics or if you head into higher level mathematics. There are two common bases, two, I don't know, familiar? I don't know, highly used. Okay, one is called the common log, and this base is base 10. Notice how there's nothing written down here. You can write 10 here if you want. I don't know why that's written twice. I have no idea why that's there. But the logarithm is always 10, okay, when it's called the common base. So if there's nothing there and you're not going to, I don't really want you guys writing it, but you can. Nothing wrong with writing it, but if there's nothing there, it's 10. The other one is base E. You remember our base E? E is approximately 2.72. Now, we don't use LOG technically. It's not wrong if you write log base E of x. It's not wrong, but it's not generally written like that. It's usually written with LN, and this stands for natural log. It's the natural log. So it has a base of E. It's just special. It gets its own special little letters. It's not wrong if you write this, but you're not going to see it written like that often. So know what LN means. That means base E. I think a lot of students will find that it's easy, or it's not easy, but it's nice to put the E there to remind them. But that's totally up to you. And I erased them over here, but if you want to put 10 in that little spot, that's fine too. All right, so let's graph e to the x. Okay, that's an exponential. So 0, 1, 1, e. Remember, it's about 2.72. Graphs are getting a little better. All right, now we're going to graph the natural log here. But this one does have a transformation. It goes right one. See this? This is your h. Okay, it goes right one. So immediately I want you guys to identify that vertical asymptote. All right, so we're going to use the points 1, 0, E1, 1, 0, base 1, and you are moving your graph to the right one, so add 1 to your x values. So you now have 2, 0, and E plus 1, if you want to write 3.72, that's okay. Technically, we really should be writing E plus 1. But it's fine because we have to graph it, so we got to know approximately where to put the point, right? So here's our 2, 0, and then we'll do 1, 2, 3.72, just a little bit more, and up 1. And here is your, that's not very smooth at all. Oh my gosh, that's not even better. Okay, I just made it worse. Let's make sure those points are visible. Okay, so our domain is 1 to infinity. Range. As x approaches 1 from the right, your y value is going down. As x goes to the right, your y value is going up, and this graph is increasing from 1 to infinity, not decreasing. Okay, so biggest takeaways. Let's have a big takeaway. You have, I think what I'd like to do is, oh, I'm so sorry. We have another one. I didn't see it. My bad. Let me extend this page. But I want to do a little summary at the bottom of this. Okay, so here we have a natural log, so that's base E, and we have two vertical transformations. We have a vertical reflection and a vertical stretch. So we'll start with our parent points, 1, 0, E1, so it's 1, 0, base 1, and we're going to multiply our y values by -2. Okay, this does not go left or right any, so I know I don't have any change in my vertical asymptote from the parent graph. So our new points will be 1, 0, E, -2. 1, 0, okay, E, you gotta go 2.72 and then down 2. So this one's gonna be facing down, opening down like this. Domain, 0 to infinity. Your range, all real numbers. There's so much more than this, and you guys will get more of this in your pre-calculus class. Like we didn't do any horizontal reflections here. 0 approaches 0 from the right, your y value is going up. Excuse me. And as x goes to the right, your y value is going down, and this is falling, decreasing. Okay, so I want to do a little thing here. I know I can draw a table, but I'd rather just write it. So I just want to do a little comparison table here. You have exponential and you have logarithmic. Okay, you're going to have horizontal asymptote. You're going to have a vertical asymptote. This is for the parent graph, okay? You're going to use the points 1, ooh, so sorry. Let's try that again. Let's try that again. You're going to have the points 0, 1, 1, b, or -1, 1 over b, if b is a fraction. Over here, you're going to use 1, 0, b, 1, or 1 over b, -1, if b is a fraction. You're going to be looking for y-intercepts. Okay. And here you're going to be looking for x-intercepts. Your domain is all real numbers here. And here, your range is all real numbers. Okay, so notice they're inverses. If you have a horizontal y equals 0, an inverse would be x equals 0. 0, 1, 1, 0. 1b, b1. -1, 1 over b, 1 over b, -1. This will have a y-intercept. This will have an x-intercept. Your domain and your range are flip-flopped, okay? So make sure that we have this down because we're going to mix it up. And if I give you a log graph on number 1, I might give you an exponential graph on number 2, and you got to know which is which. So again, we didn't do a huge, actually, one more thing, sorry. I do want to go over this again. For exponential, you have a times b to the c x minus h plus k. Oh my gosh, k. Okay, so k is your horizontal asymptote. And then for a log graph, your h is your vertical asymptote. Okay, can't really do this there. 8 h is your vertical asymptote. Anyway, not my best video, guys, but I'm hoping that will help you. And I'm sure you can find better videos than this one out there. But I thank you for watching. Have a great day.